Now, we just had a geometry question where we were given a picture and we had to draw the picture again because we needed to write so many things on it. So we would have needed our scratch paper to recreate what they already gave us. Here, we don't have any picture. So that's a good rule of thumb. If you have a geometry question with no picture, draw a picture. They are purposely leaving one out to mess with you. So it's not a hard picture, right? It's a triangle ABC and angle B is a right angle. So just draw yourself a little right triangle, right? So here you go. And here's angle B. And then for A and C, it really doesn't matter. You don't need to draw to scale. It's not really a big deal. So let's just put A at the top and C over here. And then now we can start labeling what they gave us, right? So the length of side AB is 10 root 37. And the length of side BC is 24 root 37. What is the length of side AC? So anytime that you have two sides of a right triangle and you want to find the third, you can use Pythagorean theorem. Some of you get so in your head about those special right triangles, the 30, 60, 90s, the 45, 45, 90s that they give us, that those are what you see everywhere. But we don't have any angles here, so we don't really know which one we would need to use, even if one applied, and they don't here. But also, the reason we use those special right triangles are only for situations where we don't have any sides, or we only have one side, I should say. So when we have just one side and we have an angle, then thankfully we know the ratios that will persist that allow us to fill in the other two sides. But if we have two sides, just use a good old-fashioned Pythagorean theorem, a squared plus b squared equals c squared, where c is the hypotenuse of the triangle. So in this case, that's exactly what we're trying to find. So the A would be 10 root 37. We're going to square that. And then the B is 24 root 37. We're going to square that. And that's going to be equal to c squared. So from here, I would honestly just go to Desmos. Like, I know there's going to be decimals involved, but I'm not particularly interested in that. So let me clear this out from another question. And let me just put this in. I guess the issue that you're going to have is it's hard on the tablet, but maybe with the mouse this is easier. Eventually what I want to do is I want to get c alone, right? So I'm going to need to take the square root of both sides. So if you're smart, you'll do that from the start. So we're going to have that the value that we're looking for is the square root of a pretty big thing. So I'm going to use parentheses just like I did here. I got to be really careful that I tell this thing to follow PEMDAS and GERMDAS the way I want it to. So I have 10 root 37. Let's close those parentheses. And then we're going to square that plus 24. Oh, we got to do the parentheses. 24 square root 37. And again, we're going to, see, you got to be careful. This is much easier, I think, with a computer and a keyboard. 24 root 37 squared. And so that's it. That's what we wanted. It's 158.151, but that is not an answer, right? So what do? Well, we'll just write it. 158.15, I guess, 2. Let's round. So we now need to find an answer choice that's going to equal that. So now we're just going to put the answer choices in and see what happens, right? So these are much simpler. 14 square root 37. Nope, too low. So it's not A. Choice B is 26 root 37. So 26 root 37 looks good. At this point, it's got to be B. There's nothing else you could do. So it's not like other situations where we're like plugging points into equations and we have to try all the answers and see which one works. At this point, these are all different numbers. So it's not like 2 could work. Then they would be the same number. So it doesn't make any sense. The only thing you could, I guess, do wrong here is somehow enter 26 root 37 wrong in the calculator. But we didn't, right? So we're done. I'll show you if you really want to know the way to continue this algebraically. I do think it's a good review of radicals and things like that. So let's just continue here. If I were to square these things, let me kind of start off again. I've got 10 root 37 squared plus 24 root 37 squared is equal to c squared. So when you square something that has both a radical and a kind of regular number, it's got to basically go to both, right? So we're going to square both things. So the squaring of the 10 is very easy. That's 100. And then we're going to multiply that by regular old 37, because what happens when you square a radical, it becomes back to a regular number. So that's 100 times 37. Here, I don't know 24 squared off the top of my head, so I would just do that in the calculator. 24 squared is 576. 576, again, times 37, and that's equal to c squared. So this is 3700, that I can do in my head, but 576 times 37 is 21312. Now you combine like terms, right? 21312 plus 3700 is 25012 equals c squared. And even if I, see again, if I did this algebraically, there'd still be this point right here where I'd really just want to put radical 25,012 into my calculator and just get a decimal because it's just such a messy number. I really just don't want to deal with trying to simplify this radical. But I could, basically, I would maybe just use the fact that each of these radical answer choices has a 37 and be like, okay, this thing is probably divisible by 37. So let's do that. So 25012 divided by 37 is 676. But then the process of breaking a radical down, the way I learned how to do it is you just keep going until you get to prime numbers. So I'd be like, okay, well, 676, what is that made up of, right? So I can divide that by 2, right? So that's 2 and 3, 38. So that also can be divisible by 2. So divided by 2 again is 169. So I don't even know what goes into 169. It's not a 3, right? So that would be 16. Yeah, no, that doesn't work. So I'd have to try different numbers at this point. So divided by 7, nope, 169. 169 divided by, it's not divisible by 2, it's not divisible by 3, it's not divisible by 5. It could be divisible by 11. Nope, 169 divided by 13. That works. Oh, I should have known that. 13 squared is 169. I should have known that. Now what I would do is I'd say anytime I have a pair of numbers, that pair comes out. And anything that's a single gets left behind. So notice the 37, there was only one of them. There were 2 2s, those can come out. The 2 13s, those can come out. The 676, the 338, those get left behind because we killed them. We broke them apart. So we're basically doing a prime factorization. 37 is also a prime number. So what we're doing here then is we have a 2 on the outside, a 13 on the outside, and then the radical 37 stays behind. So now we reduce that to 26 radical 37. That's our answer. And what do you know? That's what we got here. That's tedious, right? Like, I don't know. That is a lot because these numbers are so big. I have to kind of guess and check my way to simplifying that radical. But the calculator doesn't care. It will give us a decimal. We can compare decimals and we can get everything in those terms. It doesn't have to be a nice decimal for us to be able to just notice that it's the same number. So I would have done it that way. The only annoying thing is kind of setting this up in the calculator, but you could do this in several steps as well. But it is good to kind of understand where it's going and try to maybe do it in the one step or at least not round too much so that you get an answer that's similar. This is a kind of hard question though, but it's the last one in the section. So yeah, we should expect it to be hard, but hopefully we can just see that Pythagorean theorem is a very simple thing to do whenever we have right triangles and two sides and we need to solve for the third.